Welcome everyone. I'm here at HNTM. I'm excited to introduce our project AI-led loan default prediction model for small-scale financial institutions in Sri Lanka and related research papers. Let's go through it. Uh, our project helps small financial institutions in Sri Lanka like microfinance or leasing companies predict if borrowers might not repay their loans. We are using smart technologies like machine learning and AI to make this faster and more accurate than traditional models. The project is supervised by Dr. Kirti Ganavickrama and runs from February 2025 to November 2025. He is a part of our undergraduate work at the University of Governance, Department of Computer Engineering. His my team members are Bandara Nayak, Osaka, and Alconi. Moving forward, Uh, we are also presenting a related research paper, development of loan default prediction model for financial companies in Sri Lanka. The case is read by Ryu Fitti and Dr. Kirti Ganavickrama and Harida Pananda. It was also shared at the 2022 International Conference on Data is applications on 46 2022 and has three citations. You can find out on Algebra home qualifications creation to help small-scale financial institutions of Sri Lanka. Now I hand over to my team member to continue this topic.
Thank you, Nisha. I'm Chanu Bandaranayaga. Now we talk about objectives. This project has some clear goals to help small financial institutions in Sri Lanka predict loan defaults better. First, we want to test advanced machine learning models like random forest and XGBoost using big data sets of 100,000 loan records. Our aim is to build a reliable system that accurately predicts if a borrower might not repay. We will also add an AI tool to make decisions faster and more smaller. Another goal is to use cloud platforms to make the system easy to scale up. Finally, we are creating a user-friendly platform that financial institutions and borrowers can customize. With features like real-time updates to keep it accurate for any small financial institutions is Sri Lanka. Then methodology. Now let's talk about how we are making this happen. The process starts with data collection. Then, using a dataset of 100,000 loan records from a trusted Sri Lankan financial institution, plus extra data from Kaggle. Next, we clean the data by fixing missing information and removing errors to make it ready for analysis. Then we pick the most important features like loan amount, monthly income, and vehicle type to make our predictions more accurate. After that, we choose machine learning models like random forest and support vector machines and train them on 70% of the data using the other 30% to test how well they work. We check the model's performance with metrics like accuracy and sensitivity to find the best one. This structure approach ensures our system is solid and practical. So thank you. Next, I will hand over to the Anushka to this presentation. Thank you.
Now, let me take you through the dataset, feature selection, and training testing results in the research on loan default prediction in Sri Lanka. Let's take a closer look at the dataset. The dataset had 100,000 loan contract records. Each record had 30 attributes related to customer, vehicle, and loan details. Before the model training, the researchers pre-processed the data. They removed irrelevant features and also dropped rows with missing values. After this step, 98,487 routine records were had. The dataset was imbalanced with 92% non-default test, 8% default test. To choose the most useful variables for the prediction, the researchers used the method called Porta function. This technique helped them to find features with high importance to the target variable. At the end, 10 features were selected for the building models. They were finance amount, monthly income, model of vehicle, year manufacture, gender, city residence, province of residence, vehicle type, effective interest rate, monthly installment. Finally, they split the data into 70% for training and 30% for testing. Using random sampling, that conclude the explanation of methodology. Now let's go to dataset. Model selection and development. The selected models were decision tree, random forest, k-nearest neighbor, logistic regression, and support vector machine. For the decision tree, they had 64% of accuracy, but with limited performance. For random forest, they got 97.96% with highest accuracy, but with overfitting. For k-nearest neighbor, they got 59%. It got the lowest performance. For logistic regression, they got 65%. Also, the support vector machine got 95%, but with overfitting. Now let's see training and testing results. The training and testing evaluated based on accuracy, sensitivity, and specificity. Decision tree, random forest, logistic regression, and k-nearest neighbor, also SVM, had accuracy of 68%, 97%, 74%, 71%, and 98%. But only the SVM got the highest accuracy. For sensitivity, only logistic regression got highest accuracy, which is 91%. For the specificity, random forest got the 99%. For testing results, decision tree got 48%, SVM got 90%, which is the highest accuracy. For sensitivity, SVM got the 98%. For specificity, logistic regression got the highest specificity value. Now let's go to next slide.
Thank you, Ravishka and Bandar WRSL. Based on the research paper, following points outline the recommended feature work to enhance the loan default prediction model. First one is data quality improvement. Conduct a comprehensive data cleaning exercise to address errors in the vehicle model and brand fields to improve feature selection accuracy and incorporate additional features. Includes such debt service cover ratios and total liabilities from the credit information scenario called ACRI to enhance the model's predictive power. Economic overlay integration develop an overlay incorporating microeconomic factors such as market demand and microeconomic factors, GDP growth, unemployment rates, interest rates, to generalize the model for economic shocks such as those caused by events like COVID-19 pandemic. The final way is the model optimization. Further, tune the random forest to model the optimized sensitivity and specificity and explore hybrid or ensemble technique to improve scalability and interoperability for practical use in finance companies. Then we are coming to the conclusion of this presentation. Esteemed colleagues and guests, as we conclude our study on developing a loan default prediction model for finance companies in Sri Lanka, I am pleased to share the key outcomes of this research. Our work focused on the leveraging machine learning to enhance the credit decision making for motor vehicle leasing, a critical product in Sri Lanka's microfinance finance sector. Our findings highlight the random forest model as a standard for FANMA, achieving comprehensive 89.1% accuracy, and also the SPM machine learning model, which despite high accuracy showed low specificity at 11% percentage. The random forest model's balanced performance makes it the preferred choice for practical implementation, offering the robust predictions to identify potential loan defaults. However, the challenges remain error in vehicle-related data and the lack of comprehensive credit history from the Credit Information Bureau under the needs for improved data quality. The model built on free COVID-19 data also requires enhancement to account for economic shocks, such as incorporating micro and microeconomic factors like GDP growth, unemployment rates. In conclusion, this model is a significant step towards reducing non-performing loans and strengthening the financial health of financial companies by enabling faster, more accurate credit decisions. It supports the underbanked communities these companies serve. With further refinement, this model can become a cornerstone for sustainable lending practices in Sri Lanka. Thank you for your attention and welcome insights as we move forward. Thank you.